Hi, this is Nitai Gaur Mohalik, your instructor. Today's discussion is about digital communication interfaces. I will be lecturing about physical layer as regards to communication interfaces. The objective of this lecture is to understand the communication interfaces or the physical layer and their applications. When we talk about communication interfaces, then we are thinking about two systems. One is called DTE and another is called DCE. The communication happens between those two systems. DCE stands for data communication equipment and DTE stands for data terminal equipment. That's the way we define. So DTE could be a computer, DCE could be modem, or there could be another DTE. So, and we have to connect them together using the cable. And all those cables, as you know, if it is wireless also, they have been standardized. Electrically, mechanically, all those connectors have been standardized. Okay, so we are talking about all those kind of interfaces. Those connectors are called interfaces and they connect between a DTE and a DCE. There are a few examples of the connectors. As you can see that HDMI and USB-C I have shown here, just examples. There are actually two ways to connect to the devices. One type of connectors, they are called just connectors, and the other type of connectors, they are called buses. A connector is a physical device that joins DCE and or DCE to allow electrical, mechanical, or optical connections. Bus is a logical pathway for transmitting data. What do you mean by logical pathway? Logical means some kind of logic is involved when you transfer data from one place to another place, and that is achieved by buses. When we think about communication between the DTE or DCE, then we are thinking about communication model. What does it mean? That the data is actually passes through several layers, actually seven layers, and eventually it reaches at the physical layer. And all these physical layer, what I mean by those is that they are cables or it could be the wireless, but eventually there are physical connections at the end. So the data is passed from top layer to physical layer, and those layers are called application layer, presentation layer, session layer, transport layer, network layer, data link layer, and last one is the physical layer. As you can see, those physical layers actually the connectors or buses, and all other layers they have a kind of services they do. So eventually data are actually transmitted through the cable, but before the transmission they are processed, and each layer has their own way of processing the data, so that data will not be missed on the way. And this model is called ISO-OSI model, and all those layers are also called ISO-OSI layers. So the last one is physical layer. This slide is an extension of the previous slide. So as you can see, the left hand side is a keyboard, right hand side is a monitor, and the data is coming from the keyboard and is passing through all the layers, and then at the end there is a connector that is also connecting to the monitor right hand side through the cable, and there are connections. And what you see here is there is a kind of controller that actually processes the data from the transmitting end to receiving end. The data could be transmitted, or sent using the cables or using the internet or any other means. So what it says that the data is actually being processed using a microcontroller or microprocessor, and then transmitted to the receiving end. Some of the physical layer standards are RS-232C, RS-422, RS-423, RS-485, RJ45, USB, USB-C, HDMI, wireless, Bluetooth, Wi-Fi, and UART. And these are all physical layer standards, and we will be discussing about these. Recommended standard 232C, also called RS-232C in short, uh, is a standard used for serial and parallel communication purposes. They are used for display application, mouse, and the printer areas. So the standard supports 25 pin D type connector DP25, and also 9 pin D type connector DB9. We will see all those in the next slide, but this is a standard RS232. C is a communication standard as far as physical layer is concerned. This slide shows an image and also some technical information about RS232 standard, which is DP9. There are actually 9 pins, as you can see, and also the pin numbers. You don't have to remember the pin numbers here, but when you need it, you can always go over and then know what those pin numbers are. So I have been talking about standard like that. So what it means that the space between these pins, and also the space between the rows, there are two rows, as you can see, is about 0.112 inches, and the space between two pins, the space is about 0.108 inches. So those space have been designed very carefully, separated very carefully in order to not to interfere with any other devices or any kind of interferences, because electrical connections, these are called electrical connections, there must not be any short circuit. So all these specification based on this standard. So that's why I have been saying standards, so they follow the standard. This is another slide related to RS232 standard. This slide shows DB25 interface, and the DB25 has 25 pins. As you can see, there are description about the pins, but you don't have to remember all this description here. But in future, if you would like to develop, or if you would like to know manufacture these kind of interfaces or connectors, then you must know the pin numbers and what they do, and accordingly you have to design your product. And all these interfaces and the specifications are based on the standard that is called RS232 DB25 standard. There are actually families of RS232 standard. They are called DA15, DB25, DC37, DT50, DE9. This D stands for kind of D-shaped metal shield. As you can see, the contour of the interface looks like D, so that's why D is there. B stands for cell size, so it could be DB, it could be DC, it could be DE, it could be DE, it could be DA. So usually most of the time DB 9 and DB 25 are used. I mean, they are very popular. Others are specific applications, they are being used. Other standards like DC, DD, like that. Okay. So just wanted to let you know that plug is a male and socket is considered as female, and all these interfaces connectors, they support electromagnetic interference. I mean, they take care of those kind of interference. RS232 standard also includes wireless. As you can see that we have antennas here in the system, and they can radiate the signal, and inside the system we have the electronic board, they process the data, so that data will be transmitted wirelessly. The image that you see left hand side bottom, that's the processor board or electronic board. And the wireless system, wireless 232, operates 429 to 433.3 megahertz band. This is the frequency of operation, and 900 megahertz that is being used in USA, and 2.4 gigahertz for worldwide use, depending upon the specific application and device. So what in this slide, I have included some important information with regard to wireless 232 standard. What it means that you can see those two pictures. It's all about the sensitivity of the modem, For example, here is the DCE left hand side and right hand side is the DCE, and the first image shows that distance is higher than the second image. So the average sensitivity of modem in the wireless market is about minus 93 dBm. dBm is a kind of strength, signal strength or the power level at a particular point. Okay, sometimes from minus 100 to minus 114 dBm is also acceptable. And as you can see, the top image shows that the modem, the distance is little bit far, and the sensitivity is 110. So it means that higher the number means it has good sensitivity, so it can capture the signal. And the lower number, which is 92, the second image, that I mean the separation between the two devices is shorter than the first one, so that's why 92. So depending upon the number, you will be able to know uh, what is the sensitivity of that system, wireless 232 system. Let me take you to here, which speaks about Wi-Fi and Bluetooth. Wi-Fi uses 2.4 gigahertz and 5 gigahertz RF band. RF stands for radio frequency. With newer standards, Wi-Fi 6E actually utilize 6 gigahertz band. 2.4 gigahertz actually travels further at lower speeds. 5 gigahertz travels shorter range at faster speed. Choice of 2.4 gigahertz or 5 gigahertz depend on where and how Wi-Fi connections are used most of the time. Bluetooth is another standard. It uses 2.4 gigahertz band and it is called industrial, scientific, and medical RF band. These two standards, Wi-Fi and Bluetooth, are actually not RS 232. These are completely different standards and wireless standards. There are other standards also available in the market. The most popular standards are RJ45, USB, USB-C, HDMI, and we have been using these standards in many places. For example, RJ45 is mostly used for internet data transmission, and USB is everywhere in the computer, for the laptop, for all sorts of devices that we have been using. And USB-C is an extension of USB, and it's a smaller version. And HDMI we use in for display applications, projectors to display. Also, we use in the TV, for example, at home, and many other applications. These are four very popular standards, and they have all technical specification, electrical as well as mechanical, physical specification. If you would like to dig into their specification, you can, and you can explore. For example, USB has technical information about 500 pages, so you can explore if you like. But what I wanted here, that okay, these are very popular standard that are being used and also available in the market. Remember, at the beginning, I was talking about the data that is being processed and then transmitted over the communication channel or the cable or the physical layer. So, data is actually processed before it goes to the physical layer. So, how does it do? I mean, there should be a kind of processor, and this is the one actually, it's called UART controller. UART stands for Universal Asynchronous Receiver and Transmitter. That is actually a controller inside the DTE or DCE. They process data and send the data to the physical channel. So whenever the data is transmitted, the controller actually controls the channelizing the data. So it takes one byte of data and then transmits the individual bits. You know what's the meaning of byte and bit? Bit is just a single um, zero or one. Byte is composed of zero and one, but the length is eight numbers. So it takes the byte and then send the data individual bits sequentially. At the receiving end, another UART actually reassembles the bits into a byte again. So, since its data is being transmitted, so there must be some kind of rate, data transmission rate. So, UART actually is capable of up to 1.5 megabits per second. Usually, no, I mean standard UART, standard application from computer to printer, for example, those kind of UART being used, those they use 20 kilobits per second data rate. Okay, that what I wanted to let you know about UART, which is very important controller as far as transmission of data or standardization of physical layer interfacings are concerned. The question is who actually does the standardization. There are, in fact, international organizations who standardize or provides guidelines for these kind of standards. So, Electronic Industries Alliance or EIA is very popular. They standardize all sorts of communication related interfaces, and it includes electrical signal characteristics. I mean, their standardization includes electrical signal characteristics, voltage levels, for example, signaling rate, voltage withstanding level, maximum stay capacitance. These are very technical information required in order to develop those kind of interfacings, and also mechanical characteristics, the connectors and the size of the pins, length of the pins, those kind of thing, and also electronic circuits, and eventually the communication protocol. You know, the protocol means how the data will be transmitted in order to maintain the security so that data will not be lost on the way. So protocol plays important role also. What kind of protocol to be used for this specific type of application? So there are lots of different types of applications. For example, you can transmit the data from computer to computer, computer to printer, computer to another display. So it happens from one devices to another device and it depends on the application. Computer to TV screen, for example. So different protocols are being used for different applications. This slide describes RS-232 electrical specification. You know, we have transmitter and also receivers, and the RS-232 electrical specification says that whenever you design transmitter or receiver, then the voltage levels must be like this. For example, at the transmitting end, the voltage level for 0 should be between plus 5 volt DC to 15 volts DC. And for 1 at the transmitting end, the voltage levels must be minus 5 volts to minus 15 volts DC. And at the receiving end, so the capability of the receiver should have or should detect the voltage levels for 0 from 3 volt DC to 13 volts DC, and for 1 minus 3 volts to 13 volts minus 13 volts DC. So these are the kind of standard specification for RS-232 as far as electrical signaling is concerned. And the third bullet list in the left hand side shows or says that the dead area between plus 3 volts to minus 3 volts, and if the voltage lies between that level, so it's called a dead area or nothing can be detected. Okay, so these are all standardization as far as electrical signaling is concerned as regards to RS-232.